Everyone. Welcome to Easy Maths. In this video, we are going to learn about polynomials. So, whether you are an educator, you're a student, or you're just wanting to learn more, this video is going to give you specific information and importance of polynomials. You can make notes and solve the questions that I'm going to do. You can keep pausing the video and solving the questions with me. And I'm sure by the end of the video, this chapter is thorough for you and you are able to solve all questions targeted in the board exams. So let's get started. Polynomials. What is polynomial? Polynomial is a specific type of an algebraic expression. Let's understand what is an algebraic expression. An algebraic expression is a set of terms separated by plus and minus sign. And there is no rule for algebraic expressions related to the variable x or y, whatever we take. Like the example that I'm taking here, 4x square plus 5x plus 3 by x is an algebraic expression because here the terms are separated by plus and minus sign. Same way, the second example that I've written here, root x plus 1 and root x minus 1 is also an algebraic expression. But if I talk about the polynomials, these two don't fit into the category of polynomials because polynomials are algebraic expressions having the variable of x as a non-negative integer. Non-negative integer मतलब x का पावर जीरो से लेके इन्फिनिटी तक कुछ भी हो सकता है बट इट शुड बी अ पॉजिटिव इंटीजर और इट कैन बी जीरो ऑल्सो. So this in detail you've studied in grade 9. I will not go too much into detail, but yes, you should know what's a polynomial. Now these polynomials are two types in two ways. So polynomials are classified in two ways. One is on the basis of the degree and the other one is on the basis of the number of terms. If a polynomial has one term, it's called monomial. If it has two term, it's called binomial. Three term, trinomial or a general polynomial. But let's classify polynomials on the basis of degree in detail. It has degree 1. Then the polynomial can be written as ax plus b. This is the standard form for the linear polynomial. If it's a quadratic polynomial, that means it's having a degree 2. Then it is written as ax square plus bx plus c. For a cubic polynomial, the degree is 3 and it is written as ax cube plus bx square plus cx plus d. A biquadratic polynomial has degree 4 and it is written as ax to the power 4 plus bx cube plus cx square plus dx plus e. Now, degree 4 and the highest power of x is 4. So, you have to remember that. Now, the value of a polynomial. And what is a zero polynomial? Zero polynomial has got degree of x as 0. So that means it's a constant. I'll come to that later. Okay, value of a polynomial at x is equal to alpha is denoted by p alpha for any value. Suppose I'm talking about the value of the polynomial at x is equal to 2, then the value will be p alpha is when the degree is 0. Zero polynomial is when the degree is 0. But what is a zero of a polynomial? The zero of a polynomial means that value of x where the polynomial is 0. But before I give you a theoretical definition of what is a zero of a polynomial, let's understand concept. Zero of a polynomial is that value of x जहां पर polynomial cuts the x-axis. Suppose I make a graph of a polynomial x and y axis. This is the x-axis, this is the y-axis. And the point where my polynomial, suppose this is the equation of ax plus by plus c. This is a polynomial. In this case, the point where it is cutting the x-axis is called the zero of the polynomial. In case of a linear polynomial, as the name suggests, the graph is going to be a line. Whereas in case of a quadratic polynomial, now here I'm coming to a very important point. In case of a quadratic polynomial, the graph is going to be a parabola. So let's make an x and y axis. Suppose this is a quadratic polynomial. Any quadratic polynomial ax square plus bx plus c. This is a quadratic polynomial. So this parabola is what is representing the whole polynomial. And the point where this parabola, this point and this point are the solution of this polynomial. That means these are the zeros of the polynomial. The point where the parabola will cut the x-axis is called the zero of the polynomial. So if I am solving the question graphically, I can say, suppose this is 2 value, this is 3 value, I can say the zero of this polynomial is 2 and 3. A parabola can also be of the form this. In this way, I can say the zero of the polynomial is plus 2. Both the zeros are 2. It's a 1 0. We'll go into detail in the chapter quadratic equation. But for now, you should know the polynomial is represented by a parabola, and the point where it cuts the x-axis is called the zero of the polynomial. Okay. So if it is a cubic polynomial, it means it is going to cut the x-axis at 3 places. Please mind my word, cutting the x-axis, not the y-axis. Okay. But if I have to find it algebraically, the zero of the polynomial, any polynomial I'm taking, ax square plus bx plus c, this is my polynomial. So it's that value of x for which this whole expression becomes 0. That means this becomes 0, that value of x. So let that be alpha, that it is represented by p alpha is equal to 0. Then alpha is the 0 of the polynomial. I hope this is clear. Though you have done it in detail in grade 9, but still this concept should be clear before we move on to the more detail of the chapter. Now, let's understand the relationship between the zeros of the polynomial. We are talking about quadratic polynomial for now because cubic polynomial has been deleted from your portion. So we'll only focus on quadratic polynomial for now. I'm taking the standard form ax square plus bx plus c. And if it's a quadratic polynomial, that means it has two solutions. It will have maximum two values of x. Let them be alpha and beta. If alpha and beta are the zeros of the polynomial, इसका मतलब x minus alpha और x minus beta उसका उसके फैक्टर्स होंगे. फिर से बोल रही हूँ, if alpha and beta are the zeros of the polynomial, इसका मतलब p of alpha and p of beta both are zero. That means we can say px is equal to k into x minus alpha and x minus beta. If it is so, let's open the right hand side and solve it out. We open and we get the equation in this format: x square minus alpha plus beta x plus alpha beta. Now, if we compare this equation with the standard form we have taken, what do we get? We get that b is equal to minus alpha upon beta minus alpha plus beta plus into k. And we know the value of k is what? A from equation 1. So we put it as alpha plus beta is equal to minus b upon a and c upon a. This is very important. I would suggest you pause the video and write this as the notes. Very, very important part of the chapter. Moving on, to the stand how to make the questions. I am taking this lecture based on what is required in the chapter, so I'm not going to move around here and there. going into details of every topic. I will be very specific based on the questions asked in the chapter. Now, if the sum and the product of the zeros is given, how do we frame a quadratic equation? It's simple. The formula is x square minus sx plus b, where s is what? X plus alpha, and p is alpha and beta. Make a note of this. We'll do questions based on this later. Now, graph of polynomial is very important because CBSE is very fond of asking questions based on graph. So this should be very, very clear to you. The graph of the polynomial, as per the equation, the linear polynomial will have a linear graph. That means a line as a graph. The point where it will cut the x-axis will be the value of x, where p of x will be 0. So here you can see x is equal to 0 at y is equal to b and y is equal to 0. So this is the 0. This is the 0 of the polynomial. This is the 0 of the polynomial in this case. Moving on to the next quadratic polynomial, the graph is a parabola, and now, that's it about the chapter. This is what is asked in the chapter. Now, the important questions that are asked are like this, like find the number of zeros in the given parabola, seeing the graph, and if one of the zero is given, find the value of a, and if alpha and beta are given, find the quadratic equation. So, let's do practice and find what type of questions are asked and what is expected in 2025 board exam. Let's move on. It's not that 2025 board exam. These are the general trend of CBSE. They have been asking such questions based on this, and now that the portion has been made concise, the questions that are asked in this chapter are very, very limited. Let's start. Let's come to this. First question. So I have a set of 10 questions for you all. The first question is on the graph. From the given figure, find the number of zeros a polynomial is having. Now, be very careful. We are talking about the zeros of the polynomial at the point where it cuts the x-axis. Only our focus will be x-axis. Remember that in all these lines. Okay? We will not see the y-axis at all. So that's what confuses the children. Here the 0 will be 1, and in case they ask you about the value, you can also say the value will be minus 2 and 0. Same way, if they ask you to tell the value in the second case, there are two zeros and one zero is this and the other one is this. Here there are three zeros, so that means it's a cubic polynomial. 1, 2 and 3. These are the three zeros. This has one zero. This is the point. This has only one. That means equal zeros. There will be two zeros because it's a quadratic polynomial shown by a parabola, but both are zeros. Both zeros are equal. This one, 2, 3, and 4 by quadratic polynomial. So seeing the graph only you can tell what is the type of the polynomial. Moving on to question number 2. Now let's solve question number 2 side by side. The first question says find the zeros of the quadratic polynomial. So here I'm going to give you the trick where the questions are involving root, how to solve them. We first write, so the question is root 3 x square minus 8x plus 4 root 3. So the coefficient of a and the constant, the product of these two is 4 root 3 into 3 root 3, that becomes 12. Now we need to find the factors of 12 which sum up to 8. So the factors will be root 3x square minus 6x minus 2x and 4 root 3. Taking common, we don't see anything common, but there is a 3 hidden in 6. So let's break out 6 This will become minus root 3 into 2x minus 2x plus 4 root 3. Now what do we find common here? We find root 3x common. This becomes x minus 2 root 3, and here if I take 2 common, again it becomes x minus 2 root 3. X minus 2 root 3 is one factor, and root 3 x minus 2 becomes another factor. So the values of x are 2 root 3 and the other value is 2 upon root 3. Moving on to the second question, find a quadratic polynomial whose sum of zeros is 8 and the product is 12. Now, in this question, they have given that the sum of zeros s is 8 and the product is 12. So, the polynomial will be x square. So, first write the formula sx. This is plus p, where sum is equal to alpha plus beta, which is minus b upon a, and product is alpha beta, which is equal to c upon a. Now we don't need to go into all those details. We will directly write the equation as x square minus 8x plus 12. This is our quadratic polynomial. So the formula is x square minus sx plus p, and the equation is here, and in case they ask you to solve it, you can factorize it and get the value. So coming to find the zeros of the polynomial, for finding the zeros of the polynomial, you will simply do midterm splitting. X square minus 6x minus 2x plus 12, x common, x minus 6 minus 2 common, x minus 6. So x minus 2 and x minus 6 become the zeros of the polynomial. Alpha and beta are 2 and 6 in this case. Okay. So the most important part is this. You should write x square minus sx plus p as the formula, and then you directly get the equation, which you can do factorizing the equation with the help of midterm splitting. Coming to the third question, find the quadratic polynomial, the sum of, okay, coming to the fourth one. Now here the zeros are given and they are asking you to find the quadratic polynomial. That means you know alpha, you know beta. You have to find the polynomial. That means this question is the reverse of this question. You know alpha is given as 5 minus 3 root 2, whereas beta is given as 5 plus 3 root 2. Now alpha plus beta, that means the sum will be 10, because if you add these two, minus root 3 2 and my plus 3 root 2 will be cancelled, and alpha beta will be 5 minus 3 root 2 into 5 plus 3 root 2. Using the identity a minus b and a plus b, we say 25 minus 9 into 2, that is 25 minus 18, that is 7. So we get product and we get s. Now if we have s and p with us, we can directly make the polynomial as x square minus sx plus p, which is x square minus 10x plus 7. This is our required polynomial. So this might be a 3-mark question. So if you write these concepts and write the equation and solve it out, you get the full 3 marks. Moving on to the next question. If the product of the zeros of the quadratic polynomial is 3. Now here in the, I'm solving the fifth question now. The fifth question says if the product, that means alpha beta, is given as 3, write the value of k. Let's write the polynomial first. The polynomial is k minus 2x square minus 4x plus k. That means from the relationship of the coefficient With the zeros of the polynomial, we know alpha plus beta is 4 upon k minus 2, that is minus b upon a, that is 4 upon k minus 2, whereas alpha beta is c upon a, which is k upon k minus 2. Now in the question this is given to you, it implies k upon k minus 2 is equal to 3, k is equal to 3k minus 6, transposing 3k minus k is equal to 6, 2k is equal to 3, so is equal to 6 and k is equal to 3. Okay, moving on to the next question. Find the zeros if one of the zero of the polynomial. Now, in the sixth question, you have to find the zeros of the polynomial and you have to verify the relationship. How do you find the zeros of the polynomial? By simple midterm splitting. X square plus 3x plus 2x plus 6 is equal to 0, and you get x plus 2 and x plus 3 as the two zeros, two factors, and the zeros will be minus 3 and minus 2. Now, if you have to verify the relationship, you have to check that the sum of the zeros that you have got, it should be equal to minus 5 and the product should be equal to 6. You have to write the whole page explanation verifying the LHS is equal to RHS. I hope you can do this question. Moving on to the seventh one. I am restricted by time, so I am skipping the easy ones. I am trying to do all the questions which requires little help from my end. Question number 7. If one of the zeros is reciprocal of the other, that means alpha is equal to 1 upon beta. This is given to you. Find the value of A. What does this means? It implies alpha beta is equal to 1 by cross multiplication. If we know this, our most of the problem is solved. The equation here given is this. According to the polynomial, seventh question, alpha beta will be equal to c upon a, that is 6a upon a square plus 9, which is equal to 1. So we get 6a is equal to a square plus 9, which it implies a square plus 9 minus 6a is equal to 0. We can see there is identity applied, that means a minus 3 whole square is equal to 0. It implies what is the value of a that we are talking about? It implies a is equal to 3. We got the value of a. That's what we were supposed to find out. Moving on to the next question. If alpha and beta are the zeros of the polynomial, find the value of alpha square plus beta square. Many children get tense doing this question because they don't remember the concept that were taught that to you in grade 8. You remember? If you know alpha plus beta, you can find alpha square plus beta square. How? Let's do it. Alpha plus beta whole square is equal to alpha square plus beta square plus twice alpha beta. We know this identity. We are doing a plus b ka identity simply. Now, we know the value of alpha plus beta from this equation. We know alpha plus beta is given as minus b upon a, that is 3, and alpha beta is given to us as 2. Using these values, we replace this value here in alpha beta and this value alpha plus beta here. Okay, replacing the values, we get 3 ka square is equal to alpha square plus beta square plus 4. It implies alpha square plus beta square is equal to 9 minus 4, that is 5. That's what we were supposed to find. Moving on to the ninth question. Here you have to find the value of alpha. So what you have to find and what you know. Whatever they ask you to find, you have to change it in the form of alpha plus beta and alpha beta. Because this is what you know in the question. So in this question, we know alpha plus beta is minus p, whereas alpha beta is q. This is what we know. And what we have to find? To find alpha plus 2 beta, I am taking the LCM of beta before multiplication, and beta upon alpha plus 2. Here also if I take the LCM, it will become 2 alpha upon alpha. Now multiplying, I will get alpha plus 2 beta into beta plus 2 alpha, and denominator is alpha beta. So this becomes alpha beta plus 2 alpha square plus 2 beta square plus 2 alpha beta upon alpha plus beta. Sorry, upon alpha beta. So we have 2 alpha square plus beta square plus 3 alpha beta upon alpha beta. Now, what we know, alpha plus beta. So let's find out alpha square and beta square. Alpha plus beta whole square is equal to alpha square plus beta square plus 2 alpha beta. Putting the values here, p square is equal to alpha square plus beta square plus 2q. To get the values of alpha square and beta square, we get p square minus 2q. Okay, the rest of the values we already know. So let's put the values here. It will be 2 into p square minus 2q plus 3, and alpha beta was q, 3q upon q. Solving this, 2p square minus 4q plus 3q upon q will give you 2p square minus q upon q. This is your answer. This is your required answer. So what have we done? We first found out what we have to find out. We changed it into the form of alpha and beta, and then we solved out the value for alpha square and beta square and replaced these values here in this and got our answer. Moving to the last question of this. See, these are some variety of questions that I have tried to cover. But this is not sufficient for practice. You have to use either you use RS Agarwal or you use exemplar. NCERT is not enough for practice. You use any of these and then you practice and do these questions as a kind of a test or a final recap or your self assessment. Let's move on to the last question of this worksheet. If alpha and beta are the zeros of the polynomial satisfying the relationship, then find the value of k. So we know from this that alpha plus beta will be minus b upon a, that is 1 upon 2, and alpha beta is k c upon a, that is k upon 2. Now, what we have to find out? 3 alpha plus 3 beta plus alpha beta is equal to 0. That means what? We will change the, what we have to find out, we'll change it to alpha plus beta and alpha beta. Taking 3 common, we get alpha plus beta plus alpha beta is equal to 0. Putting the values from here, 3 into 1 by 2 is equal plus k by 2 is equal to 0. It implies what? K upon 2 is equal to minus 3 upon 2. It implies k is equal to minus 3. This is what we were supposed to find in the first part. The second part says find the zeros of the polynomial. So the polynomial becomes 2x square minus x minus 3, which means what? We have to do midterm splitting. The first and the last term product is minus 6. So it is 2x square minus 3x plus 2x minus 3. is equal to 0. Taking x common, 2x minus 3. Taking 1 common, 2x minus 3. And you get 2x minus 3 and x plus 1 as the factors. It implies the zeros are x is equal to 3 by 2 and minus 1. That's what you were supposed to find in the B part. This is all from my side. I hope this video was helpful and can help you understand the concepts and give you a final practice for your chapter. So if you have not liked and subscribed to my channel, please like and subscribe my channel and keep watching Easy Maths for more such videos. Stay tuned in.